Welcome to Lesson 4 on our unit of Analytic Geometry or Geometry on the Coordinate Plane. Our goal today is to review how to find slope between 2 points on a graph using the table, graph, or set of points methods, and then to use that concept to determine whether or not 2 lines are parallel, perpendicular, or neither based on their slopes so that we can use them to solve problems involving geometric figures. So our first objective, our quick review of slope, starts with reminding us what it looks like when a line has negative slope, positive slope, undefined slope, and zero slope. We will review the slope formula, and then we will talk about, in our second objective, what makes lines parallel, what makes lines perpendicular, and we'll talk about equal and opposite reciprocal slopes to compare those 2 types of lines. So let's start with, what does it look like to have positive slope? Positive slope means that a line increases as we move from left to right. So a line in that direction has positive slope. We always read a graph from left to right. So if we are going up from left to right, we say that that graph is increasing and that it has positive slope. Similarly, if we go down from left to right, we say that that line has negative slope. If the line is horizontal, then that line has a 0 slope. And if the line is vertical, we say that the slope is undefined. So in this first example, we're going to use the graphing method. So the graphing method is rise over run. So we're going to pick 2 nice points on our graph. I'm going to pick this one and this one. And I am going to calculate the change in y, which is down 2, over the change in x, which is right 4. So since it's down 2, I think of that as a negative number. And since it's right 4, I'm always going to move to the right. That means that my denominator will always be positive if you use this method, where you always run forward. So the rise can be up or down, and the run will always be forward. So my formula, rise over run, will be -2 down 2 and forward 4 or positive 4. And that's a negative slope, and 2/4 simplifies to 1/2. So my slope is -1/2. And then I want to make sure that if I get a negative slope, as I did here, that my negative slope agrees with the fact that my graph is going down from left to right. So that's a big advantage of the graphing method, is that we can see that the direction of the slope. So quick reminder, parallel lines have equal slopes, the same slope. These 2 lines here will never touch. They have the same or equal slopes. And perpendicular lines, you might remember from last year, have opposite reciprocal slopes. So if we zoom in here and we calculate the slope of each of these lines, we can see that this line goes from 9 to 3 on the vertical axis, so that's down 6, and then forward from -1 to 7, so that's 8. So the slope of this green line is -6/8 or -3/4. The slope of the blue line is, let's go from this point, find another nice point on this graph is here. So the change in y is up 4, and the change in x is forward 3. So the slope of my blue line is 4/3. And you'll notice that that confirms that relationship for us of a slope of -3/4 and a slope of positive 4/3. Those are opposite reciprocals, meaning that they multiply to -1, confirming that perpendicular relationship for us. So just as a quick reminder, opposite reciprocal means that the 2 numbers multiply to -1. To find the opposite reciprocal of a number, 3/4 for example, we flip the numerator and the denominator to make it a reciprocal, and we change the sign to make it opposite. If I have a number like -1/5, to find the opposite reciprocal, I would flip 5 and 1, that makes it the reciprocal. And then because it's negative, my opposite reciprocal would be positive. If I have a whole number, like 3 for example, I can think of it as 3 wholes, and then I can switch the numerator and the denominator to get 1/3 and change the sign to go from positive to negative. These are called opposite reciprocals. And again, the property of opposite reciprocal is if I multiply these numbers by each other, I will get negative 12 over 12 is negative 1. I will get negative 5 over 5 is negative 1. I will get negative 3 over 3 equals negative 1. So now that we remember these two relationships, we can look at a shape on the coordinate plane and determine whether or not the lines involved in that shape are parallel or perpendicular, and therefore classify the shape as specifically as possible. So let's try this example. I am going to plot points A, B, C, and D, and then I'm going to try to determine if that quadrilateral is a rectangle using the slopes. Okay, now that I have my sketch, I am ready to calculate each of my slopes. So again, I'm going to use that letter M to represent slope, and I'm going to do M of each segment. So AD, the slope of AD, which I'll denote with a little subscript of segment AD, is going to have a rise from 5 to 9. So my rise is up 4, and my run is from -5 to -3, that's +2. So the slope of AD is +2. I'm going to move on to do DC. So my rise from 9 to 7 is going down 2. I'm going to make sure to make that negative. And then my run going forward is from -3 to +1. So that's a run of 4. So my slope is -1/2, which agrees with my diagram that I am going down from left to right. BC, the slope of BC, my rise is from 7 to 3, so that's going down 4. And my run is from 1 to -1, so that's back 2, or you can think of it as going from 3 to 7, up 4, and forward 2. Either way, you are going to end up with a +2 for your slope. Looking good so far. And finally, AB, I have a slope of AB. My rise from 5 to 3 is down 2, and my run from -5 to -1 is forward 4. So my slope is -1/2. So if I zoom back out and look at this full picture here, I have a slope of -1/2 on sides CD and AB, meaning that they have the same slope, so they are parallel. And I also have the same slope on sides AD and BC. Those are parallel because they have the same slope of +2. So now I can classify this diagram as a parallelogram because opposite sides are parallel. But in this question, we were asked to determine whether or not this shape was a rectangle. So I do need to go back and think about my definition of rectangle. And the definition of rectangle is that it is a quadrilateral with 4 right angles. And right angles are formed by perpendicular lines. So I am looking for perpendicular lines as the consecutive sides. Well, when I look at 2 and -1/2, I can see that those are opposite reciprocals. So we say that the consecutive sides have opposite reciprocal slopes, 2 and -1/2, 2 and -1/2, 2 and -1/2. So now I can confirm that quadrilateral ABCD is a rectangle, and my explanation should include my calculations for the opposite reciprocal slopes, as well as an explanation saying that when consecutive sides have opposite reciprocal slopes, the segments then form perpendicular lines, which makes it 4 right angles, which makes it a rectangle by definition. Kind of sounds like our proofs from earlier in the year. So your final explanation should look something like the explanation written here. So your objective today was to be able to calculate slope, and then additionally to take that calculated slope and determine whether or not two lines meet the requirements for being parallel or perpendicular, and then using those calculations to make decisions about geometric shapes. So you are now ready for some practice.